number 1. Okay, so the polynomial 2x minus 1 times x squared minus 2 minus x times x squared minus x minus 2 can be written in this form. Okay, you're trying to find a, b, c, and d. Basically, what they're asking you for is to multiply all of that out. Okay, so I'm going to distribute, and that's going to give me 2x cubed minus 4x minus x squared plus 2, and then we're going to distribute this guy as well. Okay, give me 20 seconds. So when we distribute this, we're going to get negative x cubed plus x squared plus 2x. And then back in algebra 1, your teacher was like, hey, you're going to combine like terms. So we've got a 2x cubed minus x cubed. And so that's going to give me x cubed. You've got a negative 1x squared plus x squared. So those are just going to cancel. And then we have a negative 4x plus 2x. That's going to give us the negative 2x. And then we got that plus 2 chilling. Okay. Now they ask for what are the constants. So for A, that would be 3. I'm sorry. For A, that would be 1. For B, that's going to be 0 because there's no x squared term. For C, that's going to be a negative 2. And for D, that's going to be 2.
The unsimplified version. Because it says 2.
On the final exam. So on this next one, it says, what is the result from this first one is subtracted from x squared plus 3x minus 2. So when they say from, what they mean for you to do is write this first, then subtract this guy. Okay, so we're going to write x squared plus 3x minus 2 minus 2x squared minus x plus 6. Now I'm going to distribute that negative. So it's just going to change the signs of all of these. And then I'm going to combine my like terms. So that's going to give me negative 1x squared plus 4x minus 8. No, it's not bad once you actually like see it. But just in case, I'm going to show you how to do this. I'm like fingers crossed, and hopefully they're not going to ask you this question, but they could. Okay, so Pascal's triangle. Let's talk a little bit about that really quick. And I need like all eyes. So Pascal's triangle is this cute little triangle that has been created. Okay. And what you do is you take the numbers at the top and add them together to get the next row down. Ones are always going to be on the outside. Okay, so for instance, 1 plus 2 gives me 3. 1 plus 3 gives me 4. 3 plus 3 gives me 6. So that's how I build Pascal's triangle. Okay. I say all of that tell you that there is an easier way to actually multiply out. For instance, see what we have right here. It's to the 8th power. That means that you would have to take 2x minus y and multiply it 8 times out. Not 8 times that, multiply 2x minus y 8 times. That's going to take 5 million years. We're not here for that. Okay? So what you are going to do is you're going to go down to the 8th row of Pascal's triangle. Okay? So really quick. Why you know this? Okay. So Elizabeth said it is 1, 8. Okay. 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 So Elizabeth found the 8th row. Okay. And normally they wouldn't ask you the 8th row. They'd ask you maybe like the 4th or 5th. Okay. And what you're going to do is you're going to create a box that has 9 columns. 5, 6, 7, 8, 9. Okay. And then you would have 3 rows. Because you're going to put Pascal's numbers up in the top. You're going to take your first term, raise it to an exponent in just a second, and take your second term and raise it to an exponent in a second. I am hoping that it is not going to be on the final exam. If it is, it's going to be to like the 4th power. And what you're going to do is take all of your answer choices. I'll show you. I'll show you in a second. Okay. So we're going to plug in all of our coefficients that we just found using Pascal's triangle. We are going to take the first term and we're going to raise it to the 0 power. And then we're going to raise it all the way to the 8th power. So each time I'm raising it up a little bit more. Oop, that's 3. This would be, well, I mean, y'all learn it this year, but the rest of the time, people learn it in junior year.
You learned this last year.
Okay. Next one, we're going to take negative y, and we're going to raise it to the 8th power and then count down. Oops. I don't think they're going to ask y'all these. Yep. I'm going to show you what part is actually important. They asked you for x to the 3rd, y to the 5th. Okay. The column that you're going to look at is this guy right here. Okay. You don't care about multiplying everything else out. Normally, you would if they were asking for the expression. Thank God they're only asking for one term. And they're asking for the x to the 3rd, y to the 5th. So right here, we're going to take 56. I'm going to write this down here because I'm just out of room. 56 times 2x to the 3rd power times negative 5 to the, negative y to the 5th power.
So you go 0, 1, 2, 3, 4, 5, 6 when you're doing the powers in the second row.
In the second row, you're going 0, 1, 2, 3, 4, 5, 6, 7, 8. And then the 3rd row, you're going to count down.
8, 7, 6, 5.
Down. Okay, we're going to multiply this all the way through. So 2 to the 3rd power is going to give me 8. And then we're going to take 8, multiply it times 56. That's going to give me 448, x to the 3rd. And then this is going to make this negative. I'm going to say it again. I don't think they're going to put this on your final because it just takes really long time. Which one? I want you to write this out in expanded form. Okay. So really quick, I would go back to that Pascal's triangle. That's okay. And we're going to want the 3rd row. Okay. Now we're going to have 4 columns and 3 rows. We're going to take these, we're going to put them in the columns. Okay. We're going to take the first term and raise it to the 0 power. And then we're going to raise it to the 1st, 2nd, 3rd, and then we're going to take the second term and put it in the 1st, 2nd, 3rd, 1st, 0. Okay. Here's how to make your life a lot easier. Okay. I normally look at the first column and I look at the last column and I multiply those out. And normally that can tell me what my answer choice or like what my answers are. Okay. So in this first column, when I multiply this together, this is going to turn into a 1. So is this guy. because anything raised to 0 power is just gonna give me 1. Yep. So 1 times 1 times negative 3y cubed. Negative 3 cubed is going to give me a negative 3 cubed is going to give me what? Negative 27, right? We're going to have negative 27y cubed. So looking at our answer choices, which one has a negative 27y cubed? D has one as well as B, right? Okay. Looking at our last column, when I multiply that out, what's 2 to the third? 8. And then we got x cubed, right? So which one has an 8x cubed and a negative 27y cubed? Again, it's B or D, right? If we actually multiply these columns out, they're not going to be 0, right? They have a number. So it's not going to be B. So it's going to be D.
Wow.
Okay, I know that's still a lot of math. Again, I'm hoping that they're not going to ask you for binomial expansion. I don't think they will. This one, this was created by the same person who created the fiber. Let's go ahead and do 5. What are the solutions to this equation? Okay, so if I take this and I try to factor, that's going to be the big X. I'm going to say A times C, which is 2, B is negative 1. What two numbers can I multiply together to get me 2, but add together to get me negative 1? Multiply to get me 2, but add together to get me negative 1. John Jason, what did you say? None, right? Okay, there's not an option to factor. Okay. Normally, that's going to mean that we're probably going to have like some type of imaginary thing going on. But we're now going to have to use the quadratic formula. Huh? You can. Okay, so now when we plug in, that's going to give us 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 1 all over 2 times 2. Okay, when I simplify this, this is going to give me 1 plus or minus the square root of 1 minus 8. So that's going to give us negative 7 over 4. Looking at our answer choices, which one has an I and has a 7 underneath the radical? Okay, so my answer is C. The reason why it's written like this is because you can actually break this up into two different fractions as well as a positive and a negative version. Okay, so you're going to try to use the discriminant, but remember, you have to have it in standard form. So not all of these are written in standard form. Discriminant is going to be that b squared minus 4ac, and you're trying to determine if it's negative or not. So take a second, go ahead and make sure that these are in standard form. So that would mean that I have to move these things over to the other side. So b would be rewritten as this. Okay. Take a second, see if you can do that. So if I were to use a discriminant, that's going to give me 16 minus 4 times 2 times negative 12. That's going to give me a positive number. So that's going to be a real solution. So it's not going to be that one. On the next one, if I use the discriminant, I'm going to plug in. That's going to give me 1 minus 4 times 2 times negative 12. Again, that's going to give me a negative number. So is that going to give me a real solution or a non-real solution? Non-real. So B would be my answer. Yeah. Because if I plugged it into the discriminant formula, I would have it. 1 minus 4 times 2 times negative 12.
That's negative 24.
Oh.
Negative 24 times.
Oh, that would be positive. Okay. It should be C. So sorry. Okay, so when I plug this in, I'm going to have 4 squared, which is going to give me 16 minus 4 times 2 times 12. Now that one is going to give me a negative. So that should be C. My bad. So sorry. Okay, these inverses. Yeah. So inverses, what you're going to do is you would switch your X and Y and solve. However, there is a easier version. What you can do is, okay, tell me what the answer is for 7. Okay, it's D. Okay, so what you're gonna do is you're gonna take each one of these functions and plug it into Desmos and watch what happens. So we got negative 2x plus 5. And then what was the other one?
Negative 2x minus 5.
Is that for D? Negative x plus 5. It's okay. Negative x plus 5 over squared by 2. Okay, so watch. Okay, so we know that that's the answer, right? Like we already know that's the answer. Inverse functions are going to reflect across the line y equals x. Okay, so do you see how the red and the blue are symmetrical? Like I could take that green line and look at it and it's the same on both sides. That's how we know that they're inverses. Okay. Yep. Okay, so they're symmetrical over the line y equals x. Okay, so you could graph each one and you can see that. Okay. In Desmos, if you do this cubic function, you're gonna hit there's like a button that's like the nth root. It says like nth root, and you're just gonna type in a little 3 into that little cubby hole in order to graph it. Yeah. Okay. Desmos is your friend. Desmos is gonna carry on that one. Okay. So on the rest of this, I'm gonna go ahead and take questions. Okay. So number 19. Yeah. Okay, what is the perimeter of this guy? Okay, so we got this pool, and the pool is in this black shaded region. Okay, a lot of people are struggling with which one is it? It's this whole mumbo jumbo. Okay, so wow, that straight line. Okay, what you're gonna do is perimeter would be adding up all sides. This guy's 35. This guy is 35 from here to there. Okay. Now we're trying to figure out this part. How do you find the perimeter of a circle? It's not area. What do we call it? It's called circumference. Cool. Circumference is the perimeter of a circle. Okay. So if I'm trying to find this circle, I got a radius of 9. I'm going to plug that in. Now we're not finding the whole entire circle, right? We're only finding like 1/4 of that guy, right? So we're going to take 18 pi, which would be a whole circle, and divide it by 4. With me? So 18 divided by 4 is going to give me 9/2, right? Yep. Okay. Y'all check my math. 9/2 pi. This guy right here is also going to be 9/2 pi. With me? Okay. Again. Yeah, this arc right here. Yep. So we've got 35, 9/2 pi, 12, 9/2. Oh, I'm sorry. Yeah, pi, 35. And then we're going to do the same thing for this guy, but it's going to be half a circle now. What's the radius of this one? 15. So we're going to do 2 pi times 15. But we're going to divide it by 2 because we only want half the circle. So that's going to give us 15 pi. My answer choice is written in radians. Are there answer choices? No. Okay, cool. That's fine. All right, so then I'm going to add up 15 pi plus 9/2 pi. Okay. Plus 9/2 pi plus 35 plus 35 plus 12. I think I got everything. 12 is right here. Okay. So it should be 144.69. 144.69. Is that what it says in the back? Or is it in pi?
12 plus 9 pi.
That's okay.
That's what I got in the
Yeah, that's gonna be it.
But it's okay if you have either answer.
Yeah, that's okay. Just change that pi being from in the bottom. There we go. Should be that 157.39.
Plus 2 pi r.
Yes.
Like if I do that.
Which I add. Yeah. All right, 39. Okay. Okay. So on 39, we've got this figure and it says that PC is 10 and it says that CBD is X. And then we got BCD, that's X plus 54. Okay. Find the value of X. Okay, so how do we go about doing that? Oh, good. Thanks, guys. Okay, so really quick, we've got a diameter right here. Okay, we have a radius right here, this BC, that's radius. Okay, and then we have this guy right here. So this isn't telling us if it's a right angle or not. Like, we don't know that for sure. So we got X plus 54, and then we got an unknown angle over here. But we know that these two should be the same, right? Roughly. Right. So, yes. Yes, you may. Okay, so how do we go about solving this? I mean, this would be 20. Okay, now what? Oh, okay. We're looking for what X is. Okay, so we've got this angle is X. This entire angle is X plus 54.
Wait, it's probably 10. But, okay, so PC is 10, right?
Yeah.
And then P is the middle, right? So BP and PD should be 10.
But that doesn't help us anymore. Like, this is 10, yes. This would be 10. No, this is an angle. Yep. And this whole thing is X plus 54. BCD, I would have to assume that. So you would assume that this would be a 90-degree angle. So that would mean that we have X plus 54 equals 90 degrees.
Which equals 36. That's what it is.
No. Oh, yeah. Okay. What's 180 divided by 3? 60. So X would equal 36. But the whole thing is 90 degrees, or, well, we can't assume that this guy is the same as this, though. Does that make sense? So we can't assume that this guy is equal to this one and this one. So like, it looks like an equilateral triangle, but it's not necessarily, because they haven't defined it for us. Okay, so X would equal 36 because this guy is a right angle. Yeah. This. Yeah. This entire arc B to D is 180. Yeah. That's true. That's not gonna help us much, unfortunately. Okay, so if this is 36, that means that X is 36. Yep. Select the true statement. The length of segment CD is less than 10. Is that a true statement? Do we know? The length of segment CD is 10. The length of segment CD is greater than 10.
Yeah.
Okay, so really quick, if I have this is 10, okay, and then this guy is going to be 10. So what is this guy going to be? How do you know that? Does it say that it's equal at all? What about the central angle?
CPC, BDCBD, like CPD.
Okay, so, but this is not the arc. This is this is this guy. We're trying to find what this length is going to be. It's definitely not going to be larger than. It's definitely not larger than. Are you serious?
It says 36/D.
That's not a true statement. Okay, so the length of segment CD should be either less, it should be less than. It's not true. So on 25, we're trying to see what is the square root of -5 in the form of a plus bi. If it has a negative underneath the radical, that is going to be an I. So I'm going to rewrite this guy as I square root of 5. Since there is no other term, like there's no other number, this is it. It's just chilling like this.
Oh, that's
Okay, yeah. It doesn't have a real term. I mean, you could technically write it out as this, but it doesn't have any real part. It's okay. All right, on number 26, it asks for what's the conjugate of -4 plus 2i. Remember, the conjugate means you're going to switch the sign of the imaginary part. That's going to be -4 minus 2i. Okay, so on number 28, okay, we're going to find the quotient. That means we're going to multiply by the conjugate in the top and in the bottom. The conjugate is change the sign of the imaginary term, okay? The reason why we're multiplying is because we want to get rid of the I in the denominator. Because if you do it to the top, it has to be to the bottom as well. No, you're doing both. Because if you do it to the bottom, you got to do it to the top. Nope, multiply. So 12 plus 6i plus 4i plus 2i squared. Over on the bottom, we're going to get 16 plus 8i minus 8i minus 4i squared. All right, so let's simplify. So in the top, we're going to combine our like terms. So that's going to be 10i. Remember, I squared is -1. So we're going to switch this guy to -2. And then in the bottom, these will cancel. And we're going to switch that to a +4. When we simplify even more, we're going to get 10 plus 10i over 20. Everything out here is divisible by 10. So that's going to give us 1 plus 1i divided by 2. I'm so sorry, that's written down at the bottom.
Yeah.
So 21, which of the following is equal to 13 pi divided by 4? Okay, so what you're going to do, if you want to convert this to radians, you're going to multiply by 180 divided by pi. Okay, so if you're going from if you're going from radians to degrees, this is how you're going to do it. So the pi's will cancel. And then you'll take 13, multiply it times 180, and then divide it by 4. So that's going to give me 585. Ta-da. When I distribute this is going to give me 2i squared minus 4i. I'm going to replace that I squared with a -1. So that's going to be I plus 3 minus 2 minus 4i. I'm gonna combine my like terms. So 3 minus 2 is gonna give me 1. I minus 4i is gonna give me negative 3i. So it should be, that's cute. Oh, there it is. Yeah. Okay. I was like, where are we at? So we got a square pyramid and a sphere that have the same volume. Okay, just a reminder, spheres are gonna have the volume of 4/3 pi r cubed. And a square pyramid, if you look up the formula for this, it says something like this. It's like a squared h divided by 3 or something like that. What that means, y'all don't stop talking. What's going to happen is you're going to substitute in the stuff that they give you. So that's going to be 12 pi squared divided by 3. And we're going to multiply it by the height. And this height says 6 pi squared. When I simplify all of that mess, I really just kind of want to pay attention to the numbers, not really anything else. Okay. When I do this, that's going to give me 12 squared, which is going to give me 144 times 6. And we're going to divide it by 3. So that's going to give us 288 pi, and that would actually be to the 4th power. That was messy. We're going to take this and we're going to set it equal to the volume of a sphere, and then we're going to solve for r. So we got 288 pi to the 4th is equal to 4/3 pi r cubed. Okay, so when we divide by pi on both sides, that's going to give us pi to the 3rd. So we divide by pi on both sides. If we want to get rid of this 4/3, that's the same thing as multiplying by 3/4. Girl, you do you. Okay, 288 times 3 is going to get us 864. Divided by 4 is going to give us 216 pi cubed. And then we're going to take the cubic root. When we take the cubic root of 216, that's going to give us 6 pi. So that's going to be C as our answer. I know that's a hot mess. My suggestion to you is to get this part and then take your answer choices and plug them in. That's what I would do. Okay, 31. All you have to do is do b squared minus 4ac and seeing which one has a negative answer for that. Or you can graph and see which one doesn't touch the x-axis. So when we do this, this is going to give us 16 minus 4 times 1 times 3. That would give us a positive number, so it's not a. I would take the next one. That would give me 0. So that's still going to be a real solution. On the next one, that's going to give me a negative number, so it's B. I would use the discriminant. That's what we learned about last week. Doesn't touch the x-axis.
When it comes to figuring out which one's real and non-real, you use the discriminant.
I would. Yeah. What? That's still real. 30. Okay. Oh, yeah. Okay. But on this one, if I have I squared, that's going to give me -1, right? Stop doing things. I to the first power is going to give us the square root of -1, right? I cubed is going to give us negative I. I to the 4th power is going to give us +1. I'm so sorry. I'm so sorry. Okay. I to the 11th power. Basically what you're going to do is you're going to repeat this process over and over again. So this would be, Amy, can you pull it down? Okay, you're gonna repeat this process. So this would be the 5th, this would be the 6th, this would be the 7th, this would be the 8th, this would be the 9th, this would be the 10th, this would be the 11th. So this is going to give me negative I. And whatever the number is, I'm not taking -4 and raising it to the 4th power. Okay, obviously, since there's an I in that solution, guess what? Not good. Okay. On this next one, we have it to the 12th power. So that would be equal to 1. So that would be real. So B would be an answer for sure. On this next one, I'm sorry, on D, because we're going to skip that next one. On D, when we multiply that out, we would get a real number. We would get like one whole number. So D would be an answer. On the next one, we would not get a whole number because we would multiply this out and still get an I. And on the last one, we would also get not a whole number. So it would be B and D because when we multiply, we would get one solid answer. No I's are in our answer. We're gonna get the final.
Thank you.